Hello, we are from Group 2 will present the effective thawing process on beef steak. Introduction. Thawing is the process of bringing a frozen object from frozen to a temperature, typically above 0 degrees Celsius, with no residual ice, also known as defrosting. Thawing is frequently regarded as merely the reversal of the freezing process. The issue of the meat quality arises due to the improper handling of the frozen meat. Perishable foods should never be thawed on the counter, or in hot water, and must not be left at room temperature for more than 2 hours. Therefore, an experiment of meat thawing using 3 different methods is conducted to analyze the quality of the beef steak based on its thawing loss, pH, cooking loss, and the shear force. Methodology. First step, 3 frozen beef steaks were taken out from the freezer for the thawing process. Then, for the control treatment, the steaks were thawed room temperature for 4 hours. For microwave thawing, turbo defrost button was pressed in microwave for 5 minutes based on the weight of beef. In water immersing thawing, the frozen beef steaks was immersed for 1 hour under running tap water. Thawing loss determination. All thawing samples were weighed before thawing as W1. After thawing, the samples as W2 were weighed for thawing loss determination. Thawing loss will be calculated using the following formula. pH determination. After thawing, 1 gram of sample was weighed and minced. The sample was diluted with 5 milliliters of distilled water based on a ratio of 1 to 5 in a beaker. The pH value was determined by using pH meter. Water holding capacity determination. 3 grams of sample which is W1 was weighed. The Whatman paper number 1 was prepared and the sample was placed between the paper. The Whatman paper was covered with aluminum foil. The 2 kilograms load was pressed on the sample. After 2 minutes, the weight of sample was weighed as W2. Water holding capacity will be calculated using the following formula. Cooking loss determination. 20 grams of sample, W1, was weighed and placed into a polyethylene bag. The sample was cooked in a water bath 80 degrees Celsius for 20 minutes, or until the core temperature reached 75 degrees Celsius. After cooked, the sample was cooled at room temperature and wiped to remove excess of water on the surface. The sample, W2, was weighed to determine cooking loss. Cooking loss determination will be using the following formula. Shear force determination. The tenderness of thawed sample was determined by using Warner-Bratzler shear force. After cooking loss determination analysis, the sample was cut into 1 cm x 1 cm x 3 cm parallel to myofiber. The sample was sheared perpendicular to muscle fiber orientation. The peak of shear force was recorded in Newton N. Results and discussions. For related calculation can pause the video and review the calculations with more details. Immersing water had significantly lower thawing than microwave, which may be attributed to the shorter thawing time. Microwave has higher thawing loss, indicating that there was more water loss during the thawing process compared to immersing water. During the experiment, error may occur, such value of immersing water lower than control sample due to immersing the meat too long. Theodorakakos, Georgakis, and Likas, 1994, reported that rapid thawing of meat by submergence in water decreased the drip loss. Thawing in water itself is the traditional thawing method when rapid thawing is required. Dissolving water is the result of heat convection from the surrounding liquid to the surface of the frozen food and heat conduction into the body. Table shows that there was an increasing trend from 5.79 to 5.94 in pH, but control and microwave samples had significantly higher pH compared to water immersing, indicating the thawing methods can affect the pH. According to Sanchez, Gazquez, and Ruiz Carrascal, 2012, the increased pH of the thawed meat may be due to the breakdown of chemical bonds involving imidazole, sulfhydryl, and hydroxyl groups. Alternatively, the loss of water from the meat tissue can increase solute concentrations and lower pH. Another explanation for this finding could be the deamination of proteins by microbial or enzymatic action followed by the release of hydrogen atoms. Yu et al., 2010, stated that with the higher thawing rate, the myofibril is disrupted, and that drip and cooking loss by thawing will be affected the quality of beef. According to Savage, Warries, and Jolly, 1990, it has been reported that the loss in water holding capacity is related to the disruption of the muscle fiber structure, as well as the modification and or denaturation of the proteins. The composition of the drip has been found to consist mostly of sarcoplasmic proteins. The cooking loss was 34.2% after thawing by water immersing and 38.15% after thawing by microwave. For the control, room temperature, 41.75% of cooking loss was observed as the highest. According to Xia et al., 2012, the higher cooking loss of meat could be attributed to increased myosin denaturation and might be correlated with the longer thawing time. The lower cooking loss of water immersing in microwave compared to control was probably due to greater drip loss. The data obtained shows that lower shear force was reported in microwave thawing compared to water immersing and control. The higher shear force, the tougher the meat. In conclusion, thawing methods had significant effects on the quality of frozen meat. In this study, beef thawed at a microwave had better thawing loss, WHC, pH, and cooking loss than those thawed by the immersing water method and controlled at room temperature. Therefore, the microwave thawing of frozen beef is most suitable to minimize changes in the meat quality by thawing. The higher thawing loss and cooking loss, and also low tenderness of microwave thaw meat could have some relation with the higher losses in ATPase activities.